This is SpinLaunch, a company that literally spins and throws satellites right into space with this artillery shell. But how do you exactly throw a satellite into space? Right now, an average rocket consumes over 15,000 gallons of fuel per second to reach space. That is, without a doubt, a lot. But SpinLaunch wants to change this by using the power of velocity to basically throw satellites into space, eliminating the usage of fuel for such tasks. Satellite delivery is the first step to this goal. The secret lies in this centrifugal mass accelerator that spins the shell to astounding speeds in a matter of seconds. It gains enough speed to allow the shell to punch through the atmosphere before splitting itself and revealing a miniaturized two-stage rocket that continues its journey into orbit. The shell itself is also a unique invention. It is made of two materials, aluminum and copper. They are known to melt at high temperatures, especially by causes like hypersonic speeds. However, the system launches the shell at Mach 6 only. The speed allows the missile to swiftly go through the lower atmosphere and let the shell absorb the heat made by the speed. Thankfully, these materials have high thermal conductivity, enough to distribute the heat through the body before the heat has even a chance to slightly damage it. However, it's weird to use an artillery-looking shell, right? Not really. Artillery shells are known to have one of the best ballistic coefficient designs. Ballistic coefficiency is the ability of an object to reduce air resistance. It means it'll fly further and in a predictable trajectory. In the future, the shell could also be fitted with a parachute. Once these get down on the ground, the team can't collect them and reuse them for the next satellite throwing mission. But without this round mechanism, the shell wouldn't be able to reach space without breaking up preemptively. This mechanism, where the shell spins to the maximum speed, is actually a space vacuum. It has specialized tools inside of it that simulate radiation, the sun's heat, and even cryogenic cooling. Combined, they create the atmosphere that helps the shell to prepare for the harsh launch. That's also really useful to preserve the system's tether that spins the shell. The space vacuum minimizes the aerodynamic heating and eliminates aerodynamic effects that can damage or outright destroy the system. So far, the company managed to build one prototype at a relatively low cost of construction that has undergone countless tests to ensure its effectiveness. But today, they managed to replace the first stage of a traditional rocket launch with a system that uses kinetic energy to do this stage instead, without a high fuel consumption rate. If the technology proves to be successful in the long term, maybe we'll see a space rocket launched with a comically large slingshot. But who knows, right?